Hi all, welcome back on the channel. Today I want to speak about encoder, and encoder used on the CNC machine, especially to gauge the position on a particular axis. This one is a rotary encoder. You can turn it this way or the other way. There is a shaft, and there is a certain number of wire on it. An encoder is something very interesting because it helps to reach a pretty accurate axis. But when you use such device, you need to take care about decoding properly, the signal coming out from those type of decoder. So I create, a small board, and what I want to check is the way that the signal are getting out from this guy when we turn the shaft. So there is some specification about this kind of device, and if you look at this one, so you have here the part number. Hope you can see it pretty well, and there is some information about the wires that are getting outside from these things. But the basic thing that you have to do is to take the proper data sheet of this encoder. So basically you have to connect one wire to the plus 5 volt, another one to the ground, and there is two other wire that send the signal. And the data sheet mentioned that the signal wire need to be pulled up with a resistor to the 5 volt. So what it does mean, so you can see here, so all the wires, and let me explain it a little bit. So the red wire, I will take the stick. So this red wire is the plus 5 volts, and this black wire is the ground. And then on the front you have the white and the green, that is the two signal, and you can see that the two signal are connected through a resistor to the plus 5 volt. So it's that we call to pull up the signal to the plus 5 volt. The other thing that I needed to make a testing about the encoder, and I will need to use the encoder on the heavy duty CNC machine. I use here my bench power supply. So I connected the cable to the plus 5 volts, and the black one to the ground. So it provides the signal, the proper signal, and the proper tension to the device. So basically the way it's wired is in line with the specification, so the data sheet. And I want to share with you what kind of signal that getting outside this kind of encoder that is very used in the CNC machine. So for that I use my oscilloscope for that. And the first thing I will do, so I capture the screen for the signal. So you have the channel 1, so the yellow one is on A that we call the A signal, and channel 2, so the blue channel is on the B signal. So the device send two signals. They call the signal phases, and the phases are 90 degrees. And what they mean by 90 degrees, if you look at here on the screen, you can see that each time a signal appears at the half period of the other one. So it's why we call it 90-degree phases. So the oscilloscope is in pause mode. You can see here the red light. So I capture the screen, and there is 2 or 3 information that is useful. So you can see we have the peak to peak. So it's 5.4 volt. You have the frequency, and the frequency is directly proportional to the rotation speed. And the other information are not very useful for the purpose. So what it does mean? It does mean that the higher the speed of the shaft is, the higher the signal is sent to any kind of circuit that will decode it. That I will show you is what is doing when. So I will turn manually, the shaft. So you can see that information, and the more speed I will put, so the higher the frequency is, regarding the phase. But all the time there is always 90-degree phase on the system. So that is the purpose of the thing. And the other thing that I want to mention, so I will try to capture again a signal. So here, so as you can see in this situation, the blue signal is after the yellow signal. So it means that the channel 1 is leading, and I rotate, the shaft in a clockwise position. So it's a way also to know if you are turning clockwise or constant clockwise. And the way to know that is to see if the channel 1 is leading or the channel 1 is not leading. So I will turn, the shaft in the other direction, and we will see how the signal will get and will be captured by the oscilloscope. So I remove the pole, and I turn the other side, and I will do it again. With one hand it's quite difficult to capture a signal. So you can see now the channel 1, so the yellow one is not leading, it's the channel 2, the blue one, that is leading. And what it does mean? It does mean that I turn the shaft counterclockwise. So it's a very interesting thing. It does mean that when you turn clockwise, the A channel, channel 1, is leading, and when you turn clockwise, it's the channel 2 that is leading. So just by looking at who is leading, you can know if you are running in one way or in the other way. And it's something that is very interesting, for this kind of sensor. So the encoder basically send 2 phases, 90 degree, one over the other one, and depending on the shaft rotation, you have a channel that is leading the other one, and then the frequency, of the signal, the up and down, are directly linked, to the speed of the rotation of the shaft. So that is something that is very interesting. And the last thing that I have to mention regarding, the encoder that you have on your CNC machine. So this one, so I know it because I checked the data sheet. This kind of encoder is able to send 600 pulses per rotation. So if you make one turn 360 degrees, it will send on each channel 600 pulses. So it's also a very good way to sense, your axis on the CNC machine. I hope that those information will help, and the next step for me will be to find a way to decode this signal in a proper way, because there is one drawback, to this situation, is the fact that if you increase too much the speed of the shaft, the pulses are so quickly sent that a lot of devices will not be able to check and count properly each pulse. You can miss some pulses. So I need to check and find a way to be sure that I check properly all the pulse. In the other hand, it will be critical, and I will lose some accuracy if I'll not be able, to be sure that all the pulses are checked. So hope those information will help you. Thanks for watching, and the next time I will work on a special, on a special device that is able to decode this kind of information. So thanks for watching.